Given array of distinct integers candidates and a target integer target, return a list of all the unique combinations of the candidate. Okay, where the chosen numbers sum to target, you may return the combination in any order. So we are given an array and we are given target sum. We need to find which all combinations, how many possible, is it possible? Return the list. Okay, list all the list of unique combination of candidates, which are all the candidates I can choose, so that sum is that target number. Okay. Oh, the same number may be chosen multiple unlimited number of times. Those two combinations are unique if the frequency of at least one of the chosen number is different. Got it? So how to I think it is simple backtracking only, but finding the states. So let's say I am at 1 2 3. So I have some array, okay, and I have some target sum. Now how to write the recurrence relation? So I have to find what is solve. How to write this solve? What is important so far is it which all elements I have processed, or which element I am currently processing in this array. So let's say this one, right? That means I need to process these elements with I included. Currently I am processing I. And what is the remaining sum? Right, I need to store that set also. So that means I can say current bucket. What is the current bucket that holds all those elements which I have taken to get the target minus remaining sum, right? I think it is easy. So I can say if I take the ith element, then it will be solve. If I take the ith element, I can again take ith element, right? And it will be remaining, whatever the remaining sum, minus a of I, and current bucket will have plus ith element again, right? If I don't take the ith element, then it will be I plus 1. Remaining sum will remain remaining sum only, not minus I, and current bucket will remain same one. I think recursive equation is fine. You can write it. Let's try. So void solve which element I am processing, I, and what is the value of sum? Target is at least 40. Okay, 40 only. So int, I can say remaining sum, and set, not set, because I can choose. So let's have a vector of integer array. We can say current bucket. I think we would need this array A also, right? Yeah, because we have integer array A also. So first thing, if I take that element, one case is, if I take that element, then will be remaining sum minus a of I, and it will be A, and current bucket. Let's first not take that element. So if I don't take that element, then answer will be A, and current bucket remains current bucket, right? Otherwise I can push back I, of course let's sort this A, not required, but anyway this backtracking doesn't matter. So if I remove, if I push this and then solve it, that means I have taken this, I can again take this, so I remains, I don't increase I, and remaining sum minus A of I and A and current bucket. What is current bucket, right? So once I'm done, I can pop back and try other I. Okay, so shall I always push? Okay, so if the remaining sum is negative, what if it gets negative? Then that is not possible. So it will return and remove that element, or I can also add a check here. If it is less than so I should process it only if remaining sum is equal to 0. If remaining sum is equal to 0, whatever is my answer is vector of integer answer and vector of integer. When remaining sum goes 0, I can push in the answer, the current bucket. Whatever is current bucket, I can push and return from here. If remaining sum is not 0, what if I goes equal to n? That means A of I will fail here, so I can directly return. That is also what is n now. So int n, you can define a dot size. Okay, so int n. So if remaining sum goes 0, fine, I can put it in the bucket. I can put it inside the answer, the current bucket, and return. If I goes n, then also return. So then otherwise don't include ith element, then I plus 1 remaining sum remains same, A and current bucket remains same. Otherwise take the current bucket. So what if it keeps on, it's not required, but let's try it. So if remaining sum, they are positive only, right? Yeah, 2 to 40. If remaining sum is greater than A of I, then only do all these things. Yeah, it's called solve on 0. Remaining sum is target and vector A. Current bucket is nothing. That means I can say, can I write it like this? New vector of integer, maybe, and answer. So 0 target, A current bucket which is empty, and answer. Okay, let's see. Okay, something is missing. I think answer. So I plus 1 remaining sum A current bucket answer. Okay. You can call it V, vector of integer V, which is empty, and solve inside the target. Okay, not working. Fine, output is I can take 2 2 3, right? Or I can take 7 also. Why it is not working? Okay, remaining sum is greater than or equal to. It should work. Yeah, first go only. Okay, it was easy. Subset some problem, I think. Yeah.